In this video, we'll begin our journey into the study of probability. Understanding probability is absolutely essential to understanding statistics. When we're collecting data from a sample, we want that sample to have been chosen randomly, so that no sample is more likely to be chosen than any other sample. So to study randomness, you have to study probability. At its core, probability is a measure of how likely an event is to occur. That means if we were to repeat an experiment many times, the probability of an event would be how often we can expect the event to happen, as a proportion of those trials. The probability of an event is always a number between 0 and 1, given as a fraction, a decimal, or a percent. If an event never happens, it has a probability of 0, while if it always happens, it has a probability of 1, or 100%. If an event is just as likely to happen as not, it has probability 1/2. And we even call it a 50-50 chance, since there's a 50% probability that it does happen and a 50% probability that it doesn't. Let's look at an example. Suppose we have a jar full of gumballs, some red, some blue, and some yellow. We might ask, if we reach in without looking and pull out a random gumball, what's the probability that we get a red one? One thing we could always do is just reach in and grab a gumball, write down what color it is, put it back, and then repeat the process a bunch of times. Then we can use our data to calculate the empirical probability of getting a red. In this case, out of 10 trials, we got a red gumball 7 times. So the empirical probability for us would be 7 out of 10, 7/10, 0.7, 70%. Now that certainly works, but an issue with empirical probability is that if you repeat the same experiment again, you might end up getting different results. Maybe the next time you only get 4 red gumballs. So now the empirical probability is 4/10, or 40%. It's pretty frustrating to potentially get different answers every time. And you probably have a hunch that there's some kind of true probability of getting a red. If so, what you're thinking of is what we call the theoretical probability, which we arrive at through proportional reasoning instead of just experimentation. When all the outcomes are equally likely, we can calculate theoretical probability of an event by dividing the number of relevant outcomes by the total number of possible outcomes. For example, there are 10 gumballs in this jar, and 5 of them are red. So that means the theoretical probability of pulling a red is 5 out of 10, 5/10, or 50%. Likewise, there's a 30% chance of getting a blue gumball and a 20% chance of getting a yellow gumball. Notice, by the way, that all 3 of these probabilities add up to 1, or 100%. The relationship between these 2 different kinds of probability is expressed by what's called the law of large numbers. That says that if you do more and more trials, then your empirical probability will get closer and closer to the true theoretical probability. So even though we got empirical probabilities of 70% and 40% before, if we were to keep going, taking more and more samples, in the long run, the proportion of red gumballs would get closer and closer to 50%. Let's look at one more example. Suppose we flip 3 coins, one after the other. We might ask, how could we find the probability that we get at least 2 heads in a row? One way we could start is by explicitly writing out the sample space, which is the set of all possible outcomes. In this case, there's a bunch of possibilities. We could get all heads, or all tails, or 2 heads and then a tail, or tails, heads, tails, etc. You get the idea. All in all, there are 8 possible sequences we could get. With the sample space complete, now we'd look at our event. Which of those outcomes correspond to getting at least 2 heads in a row? That would include heads, heads, tails, and tails, heads, heads. And remember that all 3 being heads also counts for having at least 2 heads in a row. So our event we care about has 3 outcomes in it. Using the formula from earlier, the probability of our event is the number of outcomes in our event divided by the total number of outcomes. Those vertical bars, by the way, just mean the number of things in each set. Therefore, that tells us that the probability of getting at least 2 heads in a row is 3/8, or 37.5%. Now, you may be thinking that listing out all possible outcomes can get pretty tedious, except in very simple situations. And you're right. That's why in future lessons, we're going to look at more sophisticated ways of calculating probability more efficiently.